of them during enrichment. Does anyone have any other questions? Nobody? So everybody can complete the square like that? Oh. Number 32. Oh. When you change the second half of it. Oh, y'all didn't even tell me. All right. A-Rock is just slope. That's all A-Rock is. All right, give me, which one did you say, 32? Okay, I'll just run through it again, walk you through. No, fractions. All right, so I'm going to take the -2 out from just the first two. And I'm going to divide here. I'm going to leave a place to add in the parentheses, but then I'm going to leave a place to subtract the same thing outside. Okay. All right, so now I need to find my good C, and to do that, I take half of the middle squared. Oh, it is positive, sorry. Because I factored out a -2. 7 times 1 is 2 times 2 is. So I've got 7/4 squared, which is 49/16. Now, that gets added here, but I have to multiply this and this together and put it here. So -2 times 49/16. You can use your calculator for that, or you can simplify. So -49/8. All right, so -2, you take the square root of the first sign, and the square root of the last, squared. Because that's a perfect square trinomial, right? And now I need to combine these two. So I've got -4 plus 49/8. And Lucy, I think this is where your question was coming in. Because these are fractions, they have to have the same bottom before I can combine them. In order to force them to have the same denominator, I can multiply the top and the bottom by 8. So I get -32/8 plus 49/8, which leaves me with 17/8, positive. And that's it. So I just did a little quick, if I don't have a calculator, trick, which is I can simplify factors top and bottom. If you can't do that, that's okay. Leave it -2 times 49/1 times 16 and use your calculator. This would be -98/16, and I could divide them both by 2. -49/8. What else on your homework? Okay. I put in negative, but because I'm subtracting it also, it became plus. You see what I'm saying? So I had to subtract the negative. What else? So the vertex here would be negative 7 over 4, 17 over 8. Opposite sign, same sign. And the axis of symmetry would be x equals negative 7 over 4. What else? That's it? All right, are y'all ready to move on to the last bit of quadratics? As always. All right, we're going to talk about writing equations of quadratics, and then we'll talk about word problems, and that'll be it. This won't take long. I'm going to give this to you and let you work on your homework for a bit. I'm not going to focus a whole lot. We focused in Algebra 2 on quadratics. We did some word problems. We did finding the maximum or the minimum of a quadratic is just finding that vertex, right? The top or the bottom. Do y'all need a break before we start? Do y'all need a break? Okay, I'm sorry. And we talked about quadratics, right? Graphing a quadratic looks like what? What's it look like? A parabola. Right?
I need someone to make her laugh on his teaching. If you can do it, I'll give you $2. What's your favorite?
Oh my gosh, don't do that. Okay. Maximum or minimum values. Hello, Carter. Maximum or minimum values happen where on the parabola?
Up and above, at the vertex.
At the vertex. At the vertex. This is more quadratics. We already started this. We started this, and now we're going to expand on this a bit. Why? Alright, so we did a lot of analysis. If you throw a ball up in the air, right, how high does it go? We can calculate that vertex. You all remember doing this in Algebra 2? Calculate that maximum value. Oh, come on, y'all. We did do that. Oh, my goodness. We didn't throw a ball, but we did problems like, okay, so here's what we're going to do. I'm going to teach you y'all took physics, right?
We're trying.
Y'all taking physics now?
We're trying.
Some of you are taking physics. All right, I'm going to give you Carter Rent. I'm going to give you a classic free fall equation. Free fall. S is going to be my height of an object. C is my time in seconds. This is not going to work well for you, is it? Because we really.
No, I already got some good ones. I just need one more thing.
At any given time, this is a physics equation, but we use it a lot in pre-cal and a lot in calculus.
That wasn't a physics.
Huh?
That wasn't a physics.
Okay. S is your height.
I was like,
That's a V sub 0. I don't want you to get intimidated by any of these variables and the way they're written. This is just the way that it's a general, you'll want to remember type of equation because it comes up from this point forward so many times. S is your height. G is your coefficient due to gravity. Does anybody know what that is? The rate at which, if you just drop it, the rate at which something falls? Yeah, unfortunately. It's 32 feet per second or 9.8 meters per second. It's actually meters per second squared. Where do you see arrows? Where do you see arrows, Robert? Approximately, thank you. Anytime you see a sub-zero like this, that means initial, okay? That means what you start with. So this is my initial velocity. If S is height, what do you think S sub-zero is? Initial height. Gosh, this is painful. S sub-zero is your initial height. In other words, I stand at the top of a cliff that is 125 feet tall, and I chunk a rock down that has an initial velocity of, I don't know, negative 25 meters per second. Initial height is where I started. That's how high up it was. Initial velocity is how far I chunked it down to start with, okay? And this is just a plug and chunk kind of thing. But this is a quadratic equation. T is your time, as it normally is. Now, sometimes we will need to calculate the initial velocity, or the actual velocity, I'm sorry. I want to go to you want me just to give you the problems to do? How are you going to do them if I haven't showed you? Same definition here. This is how we find velocity. Initial velocity there, and then my coefficient of gravity here is my g. Let's do an example on how we use this and what it is that we find, and then I'll set you loose, because let me go ahead and tell you what your homework's going to be. And it's just using these two equations over and over.
How do we do that?
Well, I'm fixing to show you. Oh my gosh, it doesn't take that long to do this. We're fixing to do one of them together. Let's look at 61 together. 61. Yes, right. Start your homework. Put 61 at the top of your homework and copy this down. Free fall motion. These are all word problems, by the way. Together, 61.
Wait, they don't jump off anymore?
As a from the top.
No, not from the top. Like the one right here.
Midway.
No, top. Not the top.
It's not really that far.
It's really big.
All right, as a promotion for the Houston Astros downtown ballpark, a competition is held to see who can throw a baseball the highest from the front row of the upper deck of seats, 83 feet above field level. I'm going to write that down. 83 feet above the field. Well, if you think if they're on top of the stands, Carter, everybody can't sit ground level. The winner throws the ball with an initial vertical velocity. So, initial velocity of 92 feet per second. And it lands in the infield in the grass. That's what it says. It lands on the infield grass. That's what it says, on the infield grass. Oh. Okay, it doesn't matter. It lands on ground. Great, Dave. Find the maximum height of the baseball.
The maximum height?
The maximum height of the baseball. So what am I going to do? I first need an equation, right?
It's 85 feet above.
Am I going to use the velocity equation or am I going to use the position equation, the height equation? Height, because I want maximum height, right? So the height equation is -1/2, no it's not, gt squared plus velocity t plus initial velocity. Yeah, I did. So this is called, what is what called? This is the height equation. S is height. So if I want to find the maximum height, then it makes sense that I'm going to use the height equation, right? And then I can just find the max of this. But I can't find the maximum the way it is now. I need to fill in what I know. So you have to decide first, which G am I going to use? Am I going to use the 32 or the 9.8? And how do I know? Why 32? It's in feet already, and this is everything else is in feet. So for G, I'm going to use 32. The T is going to stay, right?
Let's see approximate calculation.
What is my initial velocity? What is my initial position or initial height? 83 feet. So here's my equation. S of t equals -1/2 times 32 actually, which is what? -16 t squared plus 92t plus 83. Yep. It's a quadratic. That's all it is a quadratic. This is a quadratic that opens which way? Down. So if I want to find the maximum value, all I have to do is find the vertex. And I'm going to use my calculator to do that. Okay? Now understand, when I do this on the calculator, I'm going to have this point x and y, right? The x is going to be my time, because that's my independent variable here. What is my y going to be? What'd you say? Height. That's exactly right. That's going to be my height. So if I find the maximum, I use the y value to describe the maximum height that it reached. Are y'all following me? Okay, so let's graph it on our calculator, and let's calculate the maximum. Oh my gosh. I don't know how to describe it. You're intriguing, you're interesting, and I know, you're going to have to adjust it so you can see it. Look, adjust your window. Okay, so let's look at it. How do we adjust it so we can see what we need? Shh, Carter, please. Y equals negative 16t squared. What was the rest of it? If I do a regular zoom, I can't see, right? I need to see way, way up. So I'm going to hit my window and I'm going to adjust my Y max. I might even go up to 100. I might change the scale to 10 so it gives me a tick mark every 10, but that's not really impacting. I still can't see it.
Go to 1,000,000. Go to 1,000,000.
Let's go to 500. And I'll go by 50 on my scale. There we go. Calculate the maximum. Second trace, max. Close to where the maximum is, and then I need to go to the left. All right, so that's pretty close. 1, 2.
One more.
Okay, I need to go to the left of it and hit enter. I need to go to the right of it and hit enter. And guess yes. So this tells me after 2.875 seconds, the ball hits a maximum height of 215
That doesn't
feet.
even make sense. How did you get 250 seconds? That doesn't even make sense.
What? Look at my point on my maximum. Is my equation right?
But that doesn't even logically make sense.
But they throw it up in the air super hard. It doesn't make sense to you? Yes, that's correct. That's correct. Second trace, max. Go to the left side of the maximum and hit enter. Go to the right side of the maximum and hit enter. No, you don't, Robert. No, you don't. I will help you. Stay right after class. I'll help you with your graph. Okay. You've got a couple more questions to answer, but I'm going to leave you to it.